ionic. It's ionic bond. It's permanent. You like it? Give me other example of other molecule that is strong. Water, no? Water. We are going to check water. Is this, no? We have one oxygen and two hydrogens. How many electrons have oxygen in the last orbit?
6.
Oxygen. Oxygen. Oxygen, sulfur, tellurium, polonium. What group is that?
6.
Group number 6. How many electrons? 6 electrons in the last orbit. And hydrogen? 1. Hydrogen 1. What element have more energy? Oxygen. What element attract the electron from the other one? Oxygen. And the other one release. This one release, this one release, this one complete A, 0 and 0, and the molecule is perfect. You like it? In the future, the element that release the electron will be called the anode. The sacrificial anode. You hear that word? I am going to install sacrificial anodes in my boat. Those elements release electrons, the oxygen attack that element, and the oxygen no attack the other metals, attack that element. This is the sacrificial. You know? You remember in the war, when we have one group of people here ready to start and other group of people ready to start, but nobody start. They are ready. They need one sacrificial guy. Okay, guy, you. Okay. This is the sacrificial guy. No? We are going to use the sacrificial guy. Is the sacrificial anode. Is the element that release. Anode. This is the anode. And what is the name of the element that attract?
Cathode.
The cathode. Alright? In the future, this is the cathode. We are talking about electrons, no? What is the charge of the electron?
Negative.
Is negative charge, no? And what is the charge of the protons?
Positive.
Okay. But the elements that orbit around the nucleus are electrons, negative charge, no? When one element release one electron or 2 electrons, what happens with the charge of that element? Become more positive or more negative?
More
Pay
positive.
attention. I am, for example, zinc, and I am going to release 2 electrons. At the end of the day, the zinc will be more positive because release electrons. And the other element, the oxygen, that attract electron, at the end of the day will be more negative. Okay, the cathode always is negative. And the anode release and release and release will be more positive. You like it?
You ever see a battery go into water and take it back out of the water? What's the first pulse it's eating up?
The negative. Cathode.
Positive. Positive pulse will be.
Exactly like Danny said. You remember in your car when you never check the batteries, but each year you open the hood and you see one terminal in the battery completely eroded, corroded, and the other one perfect. What is the terminal that is eroded?
The anode.
The anode is the sacrificial anode, release electrons, and the other one that accept electron is like new, the cathode. You like it? That's the explanation. Always the elements in the periodic table, they have different level of energy. What is the name of the level of energy? Excuse me?
Electronegativity.
Electronegativity. You remember that table in the book? In the table I showed that the elements located here in this corner, they have the less level of energy. How much is francium? 0.7, no? 0.7 millivolts. And how much is the level of energy of fluoride?
4.0.
4.0 millivolts is a lot, no? What is the meaning of that? And what is the level of energy of oxygen? 3.6, no? 3.5, 3.6. What is the level of energy of chlorine? 3 point something. Those elements located over there in that corner, oxygen, sulfur, chlorine, fluorine, are the elements with more energy. They destroy everything. And the elements located here in this area, they are the elements with low energy. Normally they release electrons. It's clear? The elements located over there are noble, more nobles. And the elements located here are less noble. If you put together two metals, the more noble metal try to attack the less noble. Always. The more noble try to corrode the less noble.
Just think about leaving a piece of steel outside for a week. A piece of aluminum
Exactly.
outside for a week.
Yeah, that's clear. What is the element in the environment with more energy with respect to the rest of the elements? Oxygen. For that reason, everything at the end of the day will be oxidized. No, Mr. Lopez, the fiberglass is not oxidized. Yes. Yes. What is the color of the fiberglass when the fiberglass is oxidized?
Yellow.
It's yellow, no? Aluminum is,
And it gets chalky. Touch it.
yeah, it's like a powder, no? What is the aluminum is not oxidized, Mr. Lopez? Yes. You remember that white powder? Is oxide of aluminum. Copper, yeah. All of the metals, all of the alloys, all of the elements will be oxidized. Some elements more quickly than other ones, no? What is the metal in the periodic table that is oxidized faster in comparison with the rest? Excuse me? Iron. This is the only inconvenience of iron. Iron is magic. This is the magic element in the periodic table. In my opinion, the number one, magic. The second one is carbon. Why iron is magic? Excuse me?
Sacrificial.
No. My friends, because iron, we have electricity, we have light, we have power, because the magnetic property. This is a property that only because iron. Iron is the only element with the magnetic property. Nice, no? Give me other wonderful property of iron in comparison with the rest.
The tensile strength?
Excuse me?
The PSI? The tensile strength?
Is the strongest metal in comparison. In that table, how much is the tensile strength of the iron? 180, 200 psi. How much is the tensile strength of aluminum? 60.
83.
83,000 psi. Iron is for that reason the majority of the structures are fabricated in iron. Iron alloys, no? Steels, iron. And other wonderful property is the cheapest metal over there. The cheapest is strong, is magnetic, and iron have other excellent property, better than the rest. It's the most intelligent metal. It's the only metal with good memory. What is the meaning of that? You can deformate a piece of iron a lot, and the iron returns. Yeah? You can deformate the aluminum, and the aluminum stays deformated. Yeah? Iron have excellent memory. The iron, the elastic range, the elastic area of the iron is too big. Return to the original position.
Big high riders.
Yeah. For that reason, we are going to talk tomorrow about that. If you have a shaft in a steel is an alloy of carbon and iron. the shaft of the propeller. If the shaft is bended, it's good idea send the shaft to the machine shop and they straight the shaft again. It's good idea.
No.
Some people do that, but this is not good because, for example, the shaft is bended, and you say, I have a friend of mine in Hialeah. He put the shaft in a hydraulic press and straight the shaft again, only for $50. Hey, my friend, can you repair my shaft? Yeah, no problem. Bring the shaft a little with the torch temperature. Yeah. Okay, it's straight, and you put them back in the boat. The shaft. 2 days working hard. In 2 months, the customer calls to you. Hey, my friend, I don't know what happened. I have a lot of vibration. The shaft is bended again because the shaft have memory. Right? Iron is magic. Iron is magic. You remember that the element located here, 1 electron in the last orbit. The element located here, 2. The element located here, 3, 4, 5, 6, 7, and 8. No? What about the elements located here in this yellow group?
3.
What is the name of those elements?
Transition.
Transition metals. How many electrons they have in the last orbit?
3.
3. Pay attention. Between copper, look, between this and this, you have all of them, they work with 3 electrons in the last orbit. 3. Only those elements, zinc, cadmium, and mercury, that group, they work with 2 electrons in the last orbit. You remember I explained in the video. Only that small group, 2 electrons in the last orbit. What is the meaning of that? Suppose I am going to prepare a party for kids in my classroom. I am going to organize tables with food for the kids, little kids. And I am going to prepare in the central table a lot of donuts, Dunkin' Donuts. In the other table, vegetables. And in the other table, fruits. And suddenly I open the door and enter the kids. What table disappeared in fraction of seconds?
The fruits.
The donuts. The donuts. After that, fruits. And after that, vegetables. Yes or no? But at the beginning, in 10 seconds, how many donuts you have? Nothing. No? No donuts. Okay. Pay attention. This is the oxygen. Papi, you can go. You have oxygen in the environment. And you have oxygen. How many electrons in the last orbit? 6. How many electrons need oxygen to be stable? 2. Okay. Pay attention. And you have in this table aluminum. How many electrons aluminum in the last orbit? 3. Copper is other element located here. How many electrons in the last orbit? 3. I have in this table aluminum, in this table copper, in other table steel or iron. And in this table in the middle, zinc, pieces of zinc. And I open the door and enter the oxygen. The oxygen, what is the element, the table that disappear in fraction of seconds? The zinc. Why?
It's easier to bond.
Because the zinc only have 2 electrons in the last orbit, and oxygen need 2. Oh, bam, 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 bam. When the zinc finish, okay, the oxygen start to attack the aluminum and the copper, but slow, because it's not easy. Pay attention. You like the explanation? For that reason, my friends, for that reason, we are going to protect the rest of the elements with pieces of zinc, the sacrificial anode. Look at this. Look at this. I have zinc and oxygen. Zinc with 2 electrons in the last orbit. Oxygen with 6. What element is more noble? Oxygen over there. And what element is less noble? Zinc, because zinc is here. No? Okay, the more noble. This one complete A0 and the molecule is perfect. What happened with aluminum? In order to create a perfect molecule, you need 3 atoms of oxygen and 2 atoms of aluminum to create that molecule. It's simple? No, it's like this. I have a party. And I am the oxygen. And the ladies, the zinc disappear, no more ladies. There are aluminums or coppers. But I need call other 2 friends of mine. Hey, my friend, I have a party with a couple of aluminums. Can you call to George and Steve? Because we need to go to dancing with those ladies. I need call 3 guys and other 2 in order to create that molecule. It's difficult. I spend a lot of time because I need make 5 phone calls, no? With zinc is nothing. Ping, ping, done. Dancing. Finito. For that reason, the oxygen prefer attack the zinc. It's not complicated. Okay, if the zinc disappear, the oxygen start to attack the other element. For that reason, in the Marinas, they say, okay, check the condition of the zinc. If the zinc is fully eroded, put the boat out of the water and replace the zinc for other one. If not, the oxygen attack the rudder in copper, the other metals. Now you understand?
You look at zinc differently on a boat now, right?
Now you say, oh, that's the zinc. And you know the function of the zinc is too expensive. It's a lot of, it's expensive. No, cadmium no, and it's poison. What about mercury? Mercury is poison also, and also is liquid. In natural state is liquid. I cannot use. Oh, Mr. Lopez, I have another idea. What about the elements of the group number 2? Those are metals. Those are metals. Can I use beryllium, magnesium, calcium, strontium, any of those metals instead of zinc? The problem with those metals, except one of these, is that those metals in contact with water react, explode. The only one that not explode is magnesium. Yes, you can use magnesium like sacrificial anode. Magnesium is recommended in fresh water. When you use the boat in fresh water, magnesium is the best sacrificial anode. But in salt water, the best is zinc. Yes, you can use magnesium. Magnesium is recommended in fresh water.
How often do you have to like replace those?
Excuse
the
me?
zinc or the magnesium? Do you, like when you install it, do you have to replace it? How?
Well, it depends. It depends on the bonding system on the boat, depending if there's straight current in the water, depending on what kind of metals. Like you have brass, stainless steel. Remember, white in those big boats, you see there's big zincs on that stainless steel shafts, but yeah, you have brass rudders. So then you have galvanic corrosion in the zinc is what produces that. So every time you see a hole in the zinc, just picture an electron just took off from that zinc. That's what those holes simulate.
That's important. You got to remember the difference between zinc
And magnesium.
and
yes.
magnesium.
You put magnesium in the salt water, you're gonna destroy the metal.
You'll find in stores that they'll sell. They say, in our mind, you see that piece of metal, you say zinc, and then you go to one store, it's, I'm just taking the numbers, 20 bucks. You go in another store, it's 6 bucks. It's because one's zinc and the other one's magnesium. And people will buy the cheaper one and think they're getting protected, and they're not.
They'll both be sold
Because
as
salt water or fresh water. Fresh water,
Yeah.
mag.
How the metal explodes, like what you're saying about.
Oh yeah,
The reaction.
it's because the other metals, beryllium, calcium, strontium, they have radioactive properties, like uranium. I'm going to explain later why the people you hear about enriched uranium. I'm going to explain what the meaning of that. Okay. But it's because they have properties, radioactive properties.
We're talking about liquid fuels before. Where are those used?
Well, back in the day, they used to use mercury for thermometers.
For the thermometer. Mercury have that property that Dan is saying. Mercury have a wonderful property. Mercury, when the temperature, the environment temperature change a little, the volume of the mercury increase or decrease. For that reason is used in the plastic container, and when the ambient temperature change, the level of the mercury goes up or down. Yeah? This is the property, and it's used in millions of applications. In air conditioning, we are going to use a sensor to check the temperature of the air before the air enters in the unit. And internally, the sensor is full of mercury. We are going to use mercury in the thermostats. The thermostat of your car internally have mercury. Yeah, it's used to sense change in temperature, because this is the property of mercury. Okay. Any other question? You enjoy this explanation, my friend? It's important, no? It's very, very important. I forget to mention this. You see that division in between the blue elements and the green elements? That division? What happened with the elements, the blue elements located over there? They are? Excuse me? No? No. And what happened with the element here behind of the division? They are metals. And the other ones? Non-metals. Metals and non-metals. All of the elements located here are metals. Mr. Lopez, calcium is metal. Yes, it's a metal. Sodium is, yes, sodium is a metal. All of those elements except hydrogen, you see the color? Hydrogen should be located here. It's a non-metal. But because hydrogen have only one electron in the last orbit, is located here. But it's not metallic. It's non-metal. That's clear, my friends? Okay. The elements located over there are non-metals, and the elements located here are metals. It's clear? Okay. What about those elements, those green elements, boron, silica, germanium, located in between the non-metals and the metals? What is the name of those elements?
Metalloids.
Excuse me?
Metalloids?
Metalloids, or semi-metals, metalloids. Later we are going to study those metalloids.